Part A, question 1. The difference between electron current and hole current is electron current flow from negative to positive end, while hole current flow from positive to negative end. Question 2. Phosphorus is pentavalent elements. 4 electrons form covalent bonds with the surrounding silicon. The 5th electron is left unbonded and become a free charge carrier, forming n-type semiconductor, which electrons are majority carrier and holes are minority carrier. Then question 3. The function of transformer is scaled down AC voltage. For bridge circuit, it is used for rectification, and capacitor is used for filtration, and last, Zener diode is used as voltage regulator. Part B, question 1. So this is the given original circuit, and we need to change it to become a Thevenin circuit. So at the first, we need to find Thevenin voltage using voltage divider. Since the diode has been removed from the original circuit, so it becomes a open circuit, and these two resistors is not considering in our calculation. So we're using the voltage divider formula, and we find out the Thevenin voltage is 1.5 volt. And now we need to find our Rx. Rx is the resistor, Thevenin resistor. So R1 and R2 both are parallel and it's series with R3 and RL. So we're using the formula and calculate of 650 ohms. We already changed the original circuit to the Thevenin circuit. Now we're using KVL. We found that the equation is this. So when VD is equals to 0, we find out that ID is equals to 2.31 milliamps, and when ID is equal to 0, VD is equals to 1.5 volt. Then we plot the graph, and here we plot 2.31 and 1.5, then connect it, and this is the Q point, intersection point, Q point. So Q point, then we determine the values, and then the operating point is this. So for question B, calculate the resistance of the diode. We just use the formula Ohm's law to find out the resistance. So VDQ over IDQ equals to RD, then we substitute the point just now we found, and we calculate the resistance is 625 ohm. So for question C, explain what happens to the Q point if the input voltage is increased by 50%. So the Q point will become higher because IDQ and VDQ increase. So from our calculation, we increase the input voltage. We increase the input voltage and we calculate the new Thevenin voltage is 2.25 volt. Then the resistance is remain unchanged. Then from the equation, we calculate. Then ID becomes 3.46 milliamps and VD becomes 2.25 volt. So 3.46 is here, and then 2.25 is here. So we connect it. So the new Q point is higher. So for question 2, this is the original circuit, and then we need to sketch the output voltage waveform. At the first, we need to find out the secondary RVRMS. So using the formula, and then we substitute the value, and we found that the V secondary RMS is 16 VRMS. Then we need to find the V secondary peak voltage. Then using a formula, we found that V secondary peak is 92.63 volt. Because this is a central take transformer, then we need the V peak, but peak voltage is half of the V secondary peak. So we need to divide by 2 to find out each voltage, peak voltage. Then we need to find the output voltage, which is the VP minus with this 0.7 and minus with this, because of D3 is an ideal diode, so it don't have voltage, 0 voltage. So we found that V output is 10.615 volt. Then we draw the waveform like this with the peak 10.615 volt. Then we need to determine the average output voltage. So using the formula, the V average is 2 V0 over pi. So we substitute the value, we get the value is 6.76 volt. And then for the peak inverse voltage, PIV is the V secondary peak over 2 plus V0. So we substitute the formula, substitute the value, and we get that value of PIV is 31.93. So for question 3, this is the original circuit. Then we need to calculate the range for RL. So since the Zener diode is functioning, so VL is maintained at 8 volt. So by using a KVL, then we get that VIS equals to V in minus VZ. So 50 minus 8 equals to 42 volt. Then we find the IR. IR is 42 over 1.2K, is V over R. So it becomes 35 milliamps. Then we need to calculate the IL. Since the question has mentioned that the range of RL, so we have maximum and minimum. So for the case RL is maximum, the IZ is also maximum. Most of the current will flow through it here. So we get the IL is 35 milliamps minus 30 milliamps, so 5 milliamps. Then we use the Ohm's law, and we get that IL is 1.6K ohms. For minimum RL, the IZ is also minimum, which is 0 ampere. So IL is equals to 35 milliamps. Then also again, we found that the resistance for RL minimum is 228.57 ohms. So the range for RL is this. Okay, now for B, calculate the maximum power dissipated by the Zener diode. So we just using the formula P equals to VI, then substitute the value, since the value VZ is 8 volt, and the maximum current for Zener current is 30 milliamps. So 30 milliamps becomes 0.24 volt.